So now what I was telling you that the geometry of a sp3 dehybridization is one is uh, trigonal bipyramidal. Okay, it is trigonal bipyramidal. Okay, so how we are going to draw this trigonal bipyramidal check? Okay, the first orbital, there will be three orbitals. In fact, there will be three orbitals. Okay, first orbital, second orbital, three. That will be at an angle of that will be at an angle of 120 degrees. Okay. We are not drawing those lobes which are not going for hybridization. That is understood. They will be very smaller in size. Okay. Now, I will draw two orbitals, which one is like above the plane, one is below the plane. So these are the five hybrid orbitals. These are the five hybrid orbitals. And where will be the chlorine atoms coming? The first chlorine, it will come over here. Since chlorine is a P block element, it will have P orbital. Second chlorine, this will be third chlorine atom, fourth chlorine atom, and fifth chlorine. So all are sigma bonds. That means all are single bonds. So five single bonds for phosphorus. So this is PCl5. Okay. So this geometry is called as trigonal bipyramidal. Trigonal bipyramidal. And now see, over here, uh, I will just explain you regarding the bond angles and look at the geometry. This is the geometry of a trigonal bipyramidal. If you can see this properly, this is a trigonal bipyramidal geometry. Can you see this black color atom? This one, this three black color atoms. So they lie in the same plane. So that's called trigonal. And bipyramidal means one bond is above the plane and one bond is below the plane of that triangle. Got it, madam?
Yes, sir.
So this is trigonal bipyramidal. So where are the five chlorine atoms? See, this is first chlorine, second chlorine, and the black color chlorine atoms. Uh, they are in the same plane, and the red color one is above the plane, other one is below the plane. Now look at the bond angle. Now you carefully tell me what will be the bond angle between this red color bond and this black color bond. What angle can you see from the diagram? See, it is making a L shape. So the bond angle will be 90 degree, correct?
Yes,
So one bond, so till now there is one bond which is of 90 degree. Okay, these two atoms. What will be the bond angle between this red color atom at the top and this black color atom? See, this is also forming a L shape. If you can see this
19.
90. And again with the third chlorine over here, which was behind. See, this is also making L shape. 90 degree हुआ. So the chlorine which is at the topmost position, that is the red color wala chlorine, it is making three bonds which are at 90 degrees. Now you look at the bottom chlorine, this one. What is the angle between this chlorine and this chlorine? What shape can you see? L shape. So this is 90 degree. Similarly with this atom is also 90 degree, and with this atom is also 90 degree. So the top chlorine is making three bonds at 90 degree, and the bottom chlorine is also making three bonds at 90 degree. So in all, how many bonds are at an angle of 90 degree. 6. 3 from above, 3 from below. Now look at this. What will be the angle between this chlorine and the bottom chlorine? The two red color, 180, very good. So there is one bond which is of 180 degree, 6 bonds which are of 90 degree. Now, how about this? What is the bond angle between this atom and this atom? Sorry, this atom. These two atoms. If you can carefully see. What is the angle between them? What is the angle between these two atoms? Or suppose if I ask you what is the angle between this atom and this atom? Can I say it is 120? See, all these three black color bonds, first, second, and the third one, they are forming a triangle. Can you see this? See this. Now
Yeah.
you will be able to. If you join this atom to this atom, and then if you join this atom to this atom, and then this atom to this atom, it will form a triangle. So this two angles, the angle over here will be 120 degrees. It's just like trigonal planar which we have done earlier now. 3 blades of a fan. So these are the 3 blades of a fan. So the angle between the any two bonds will be 120. So ये दोनों के बीच में 120, ये दोनों के बीच में 120 और ये दोनों के बीच में 120. So there will be 3 bonds which will be at an angle of 120 degree. आपको समझ रहा है ये मैडम? Okay. Now look at this, something very important. What is the angle between this bond and this bond you told me? कितना है angle?
90.
90 degree. Okay. और ये जो ब्लैक कलर के बॉन्ड्स है उनके बीच में कितना एंगल बोला अभी हमने? ये ब्लैक कलर के बॉन्ड्स में दो ब्लैक कलर 120 बोला ना हमने?
20.
हाँ. Can I say the repulsion between the electrons will be more at 90 degrees than at 120 degrees? Because at 120 degree, the bonds are far away from each other. As compared to 120 वाले, they are far away. तो 90 डिग्री वाले में थोड़ा रिपल्शन ज्यादा होगा. मतलब ये बॉन्ड में रिपल्शन ज्यादा होगा. It is called bond pair repulsion.
Yes.
Just to this bond pair repulsion, these bonds, they extend their length. मतलब they go very far. The bond angle will not change, but they will go far. So as to minimize the repulsion between this bond, black color and red color bond. Now remember this. These red color bonds are called axial bonds. क्या बोलने का उनको? Axial bonds.
Axial bond.
And other bonds, they are called equatorial bonds. So there is a very important concept in a trigonal bipyramidal geometry which says that axial bonds are greater than equatorial bonds, which means the bond length of axial bonds is higher as compared to that of equatorial bonds, even though all the bonds, they have the same side atom, that is chlorine in this case. Why such a thing is happening? Because you will say that axial और equatorial के बीच में 90 डिग्री है bond angle, whereas equatorial के बीच में 120 डिग्री है. So 90 डिग्री वाले में repulsion ज्यादा होगा. So to minimize the repulsion, they extend their bond length. And this rule is called as Bend's rule. क्या बोलने का इसको मैडम? Bend's rule. B-E-N-T-S. B-E-N-T and then apostrophe S. So Bend's rule says that in a trigonal bipyramidal geometry, ध्यान से सुनना है, a trigonal bipyramidal geometry in PCl5, okay, we will say that the axial bonds are greater than equatorial bonds. Okay, Bend's rule का और भी बहुत ज्यादा मतलब है. Actually इसमें Bend's rule नहीं लग रहा है because all the side atoms are same. इसमें तो आप सिर्फ ये बोलोगे कि due to bond pair repulsion between equatorial and axial bonds, okay, the bond length increases for axial bonds. समझाइए?
Yes, sir.
यहाँ पे बेंच रूल मत बोलना. बेंच रूल कब लगाना है मैं आपको बाद में बताता हूँ जब वो टॉपिक पर आएंगे. So I will write it down over here, some things. And what are those some things? I will say that one minute. Sharing my screen. I'm not able to share screen. Hmm. Yeah. Now, what I was telling you that there were six bonds of how much angle? 90-degree angle.
Yes.
Then there were three bonds which are of 120-degree, है ना?
Hmm.
And there is one bond which is of 180-degree. Got it?
Hmm.
So this is what we need to know very clearly, that how many bonds are at 90-degree, how many bonds are at 120 and 180. Just copy down this thing and let me know once it is done. You understood this geometry now, madam? Trigonal bipyramidal geometry.
Yes, sir.
Then,
Then.
okay. Now the next hybridization that we have to do. So what are the hybridizations that we have completed? Tell me.
Did SP3,
Hmm.
SP3, SP2, and SP3D.
Yes. So now we'll go for SF6 hybridization. The central atom is sulfur and its atomic number is 16. So configuration will be 1s2, 2s2, 2p6, 3s2 and 3p4. Got it? So now ground state. Ground state. Ground state is 3s2 and 3p4. We'll see whether it needs excitation or not. So we'll have 3s2 and 3p4. Like, so there are only three electrons. Sorry, two electrons which are unpaired, but sulfur is making six bonds. So obviously there is a need for excitation of electrons. So say this is our D subshell. So D subshell has how many orbitals, madam?
5.
Ah, very good. So how many electrons should migrate? Two, so that it will have six unpaired electrons. So one electron will go in D orbital and the other from 2s. So how many orbitals it is having now? Six. So the hybridization now will be, what will be the hybridization? You tell me, chalo. Count how many s orbitals, how many p orbitals, how many d orbitals are there.
SP3, SP3D2.
Sp3d2. Yes, the hybridization will be sp3d2, and wherever it is sp3d2, it is a octahedral geometry. So six orbitals have to be there, hybrid orbitals. So uh, let let's draw the hybrid orbitals now. Hybrid orbitals, there will be six orbitals, and all six will have the same name, that is sp3d2. So second, Okay, and all of them has one unpaired electron. And how are you going to arrange them in space? In the form of octahedral. Now, how does the octahedral shape look like? Okay, it will be four orbitals like this.